Imagine when your new friend only knows French. Can you make him understand what you want to say with your English? No, right? So, you may need a friend who knows how to translate English to French. Similarly, the program we write in C language cannot be understood by CPU. So, we need a translator for CPU. Welcome to JJ Coders. CPU only knows the machine language. So we need something that translates our C program into a machine language. This is where compiler comes in. C compiler is a program that translates the human readable source code written in the C language into machine code that the computer CPU can execute. The C compilation process typically involves four main stages. First stage is the preprocessing. This is the first phase handled by the C preprocessor. It modifies the source code according to preprocessor directives. Header file inclusion. The content of specified header files, for example, hashtag include stdio.h, are inserted directly into the source file. Macro expansion. Textual substitution defined by has defined or performed. Conditional compilation. Sections of code are included or excluded based on directives like hash if def, hash if and def, and end if. Command removal. All commands are stripped from code. The output of preprocessor is a pure C source file ready for the next stage. Stage 2 is compilation. The compiler takes the preprocessed source code and translates it into assembly code, a low-level language specific to the target CPU architecture. Example x86 or ARM. Lexical analysis. The source code is broken down into a stream of tokens, keywords, identifiers, literals, operators. Syntactic analysis. The stream of token is checked against the C language grammar rules. If valid, an internal representation called an abstract syntax tree AST is created. Semantic analysis. The AST is checked for semantic errors such as type mismatches and undeclared variables. Intermediate code generation. A high level machine independent intermediate representation IR is often generated. Code optimization. The IR is analyzed and transformed to improve performance. Example, reducing instruction count, improving memory access. Target code generation. The optimized code is converted into the assembly language specific to the target machine. The output is an assembly file. Example .s or .asm. The third stage is assembly. The assembler takes the assembly code and translates it into machine code instruction. These instructions are packaged into a relocatable object file for the linkers. The assembly mnemonics like move, add, jump are converted directly into binary machine code. The object file contains the machine code, data, and symbol tables that listed the functions and variables defined in the file and those its reference from other files. The output is an object file. Example .o on Unix-like systems, .obj on Windows. The fourth and the final stage is linking. A program rarely exists in a single object file. It usually relies on code from other object files and libraries like the standard C library. Relocation. The linker resolves the temporary addresses assigned by the assembler and assigns final absolute addresses to the code and data. Symbol resolutions. It resolves all external reference. Example, calls to functions like printf and scanf by finding the corresponding machine code in other object files or specified libraries. Executable creation. All the resolved object files and library code are combined into single cohesive executable program that is ready to be loaded into memory and run by the operating system. The output is the final executable file. Examples, a.out on Unix-like system, .exe on Windows. In our next video, let's see how to install a compiler and run your first C program. Please like, share and subscribe. Thank you and see you in the next video.